Hello class, welcome back to another section of our intensive calculus course. We go as we progress. We've done so many topics. In this class, we are going to continue with applications of differentiation. How do we apply differentiation in solving practical problems? Under this, we're going to look at the L'Hopital's rule. You take the rule 1, rule 2, and the rule 3. You go forward to do the rule 4 in our next classes. So, if this is your first time visiting this channel, don't forget to like, subscribe, and also share. Watch this video to the end so that you understand this rule very well. L'Hopital's theorem or L'Hopital's rule. This is used in the analysis of limit problems where we have the indeterminate forms. So L'Hopital's rule is actually used to solve indeterminate limit forms. The rule 1 deals with quotients. So if you have quotients as a function, which we call the rational function. So if you have f of x over g of x, where g of x is not equal to 0, we say it is a rational function. When we are given a limit of any function, any rational function, and it happens that you get an indeterminate form, example 0 over 0, then infinity over infinity. These indeterminate forms can be solved simply by applying the L'Hopital's theorem. I have an example which I'll use to demonstrate how we do the L'Hopital's rule 1. So evaluate the limit of the expression as x approaches 1, ln of x over x minus 1. To apply the L'Hopital's rule, the rule says we should differentiate the first function, that's the numerator f prime of x, over g prime of x. Then we apply our limits. So let's see. We've done derivatives of lim function. So if you have ln x and I want to differentiate ln x, I will simply get 1 over x. Then if I have x minus 1, which is a linear function, if I want to differentiate, I'm going to get 1. So simply this becomes 1 over x. So after doing this, then we apply our limit value. So our limit value will simply be 1, we put it inside, so meaning our limit is equal to 1 over 1, which is equal to 1. And that is how we apply the L'Hopital's rule 1. Let's take the L'Hopital's rule 2. L'Hopital's rule 2 deals with products. It deals with products. So if you have product of two functions which gives an indeterminate form after you have applied a limit at a certain point, then you are supposed to use the L'Hopital's rule 2. So let's see the L'Hopital's rule 2. So if I have f of x multiplying g of x, and after doing it, I am getting an indeterminate form, say 0 times infinity. This is an indeterminate form because if you multiply 0 by infinity, you can't say it's 0, though any number times 0 is 0. So this is indeterminate. So if you apply limits and you end up getting such an expression, you have to apply the L'Hopital's rule 2 to aid in your simplification. How do we do that? So L'Hopital's rule 2 says you have to modify your products into a quotient. So this can be done by giving f of x over 1 over g of x, which literally we have done nothing to this function. So if I'm to reverse this, you realize that this is equal to f of x times g of x over 1, and I still get my product back again. But once you express it in the quotient form, simplification becomes very easier. Then we differentiate the top, so you're going to get f prime of x over then 1 over g of x all prime. Then after we apply our limit function or limit value, sorry. So let's take an example here. I'm going to have evaluate limit as x approaches positive 0 of the function x ln x. If I put 0 into this straight away, it's going to give me an indeterminate form. So what do? this is going to be expressed as a quotient form. So I'll get ln x over 1 over x, where this one is the same as this. You just put 1 over the first one and you bring it down here. So after you've expressed it in this quotient form, the next thing to do is to differentiate the top, then you differentiate the down. So if I differentiate ln x, I'm getting 1 over x over, when I differentiate 1 over x, this is the same as x to the power negative 1, and I'll multiply negative 1, so negative x to the power negative 2. Therefore, I'll get an expression as 1 over x over 1 negative 1 over x squared. Further simplification, 1 over x times negative x squared over 1. Therefore, I'll be getting negative x. Once I get negative x, I'm not done. I have to apply my limit value, which is 0. So my limit of x ln x as it approaches positive 0 is simply negative 0, and that is giving me 0. Let's take the L'Hopital's rule 3, which deals with exponents. Which deals with summation and also the subtraction. So if you have f of x plus or minus g of x, and the resulting solution after applying limit at a certain point gives indeterminate form, then we can apply L'Hopital's rule 3, which says you have to simplify. The word is simplify. Simplify this expression to get a quotient. L'Hopital's rule is interested in quotient, so always make sure you simplify to get a quotient, then you differentiate the numerator, then you differentiate the denominator, then after you apply your limit value. So here you have to make sure that you modify this, then you get a quotient. So let's see an example here. I have find the limits of sec x minus tan x as x approaches pi on 2 from the left side. So this is two functions which we are subtracting from each other. Yes, so this is an algebraic function. It deals with the operations on polynomial, trig, and other functions. So let's see. If I have this, what the rule is saying is I have to express this as a quotient. So my sec x, which is the inverse, the 1 over cos x, yes, minus tan x is also cos x, sin x over cos x. When you have something like this, basically, if you have the same base, you have to subtract the numerator. So 1 minus sin x all over cos x. Then I differentiate the top, I differentiate the down. When I differentiate the top, I'm going to get negative cos x. When I differentiate cos x, I'm going to get negative sin x. The negative and the negative will vanish away. I'm going to get cos x over sin x. I apply my limit value, which is pi on 2, cos pi on 2, which gives us 0. Then sin pi on 2, which gives us 1. So 0 on 1, which is simply 0. This is the end of this class. If today is your first time visiting this channel, don't forget to like, subscribe, and also share. More examples will be posted in the next class. Don't forget to join those classes. Thank you.